Well, hello everyone. I thought I'd start walking through some of these questions. I'm going to base it on the assumption that you guys want me to walk through some of these technician class questions and go through the answers if it seems appropriate. So, here we go. Using the QRZ site, by the way. So this question, how many volts are equal to 1 kilovolt? Well, in this case, kilo meaning 1,000, and of course volts are volts. So 1,000 volts would be that answer. Okay, now that's funny, isn't it? We just went in the other direction now. How many volts are equal to 1 microvolt? Micro is 10 to the minus 6, which is 6 decimal places to the left. So I believe that the answer is 1/1,000,000th of a volt. That's almost hard to say. Could be a sobriety test, perhaps. Next. Which of the following is equivalent to 500 milliwatts? Milli meaning a thousandth of a watt. So there would be 1,000 milliwatts in 1 watt, and 500 milliwatts is half of that. Therefore, it would be half a watt. Let me move this window over just a little bit and get these ads off of here. There. Much better. If an ammeter calibrated in amperes, which is a unit of current flow, by the way, is used to measure a 3,000 milliampere current, what reading should it show? Now they're asking what reading should it show in amperes. Again, milli meaning 1,000th. Therefore, there are 1,000 milliamps in an amp. So because this is 3,000 milliamps, that would be three times that, or 3 amperes. If a frequency readout calibrated in megahertz showing a reading of 3.525 megahertz, what would it show if it were calibrated in kilohertz? Well, the difference between kilohertz and megahertz, let's start from the beginning. Of course, hertz are basic units, especially if you've just gone through a divorce. Oh, wait, I didn't really say that, did I? So kilohertz is 1,000 hertz, and megahertz is 1,000,000. So kilo is 3 decimal places, and megahertz is 6, so the difference between the two is 3. So you would want to move this decimal point 3 places to the right, which would give you 3,525 kilohertz. Ah, new unit. Cool. Actually, 2 new units in it. Well, no, I think we did micro, because we did microvolts there earlier, so that's not new, but pico is. And the difference between micro and pico is actually 6 decimal places, so that's fun. Microfarads would be 1 microfarad would be 1 times 10 to the minus 6, and 1 picofarad would be 1 times 10 to the minus 12th. That's a lot of zeros to the left there, folks. So they want to know how many microfarads. It's 6 places. If you go from microfarads to picofarads, which is a smaller unit, the number's got to get bigger. So you have to go 12 decimal places to the right. So that'd be have I confused myself? Oh, I take that back. I got that backwards. It says how many microfarads are that many picofarads. So you're going 12 decimal places to the, or excuse me, 6 decimal places to the left. So it's 1, 2, 3, 4, 5, 6, which makes that 1 microfarad. Confused myself there for a minute. That's the fun of doing these on the fly, right? All right. Let's see what we got here. What is the approximate amount of change measured in decibels of a power increase from 5 watts to 10 watts. Now, if you've watched my video on a quick guide to decibels, it stated two very important things. One of which was if there was a 10 dB change, like this down here, you'd just be adding 1 0 to the number, or, well, I should say moving the decimal point 1 to the right. Or if it's attenuation, it would be to the left. If it's 20 dB, it's 2 zeros, 30 dB is 3 zeros. You look at that first number and move at that number of zeros. So, and then 3 dB is either half if it's attenuation or twice if it's an increase, like from an amplifier such as that. So, what is the approximate amount of change measured in decibels of a power increase from 5 watts to 10? They're doubling the power, so that has to be 3 dB. What is the approximate amount of change measured in decibels of a power decrease from 12 watts to 3 watts? Well, you can't really follow a 10 dB rule, and it doesn't matter because there's no 10 in there as far as the answers are concerned. Move that up where you can see it. So, well, what we do know is 3 is a multiple of 12, 4 times to be exact. So, if you're going to go from 6 or 12 watts and half it, which would be 3 dB, that'd be 6. And then you halved it again, that'd be 3. So if you cut the power in half twice, that was 3 dB each time. Hence, it would be 6 decibels, or 6 dB. Last question in this quiz. What is the approximate amount of change measured in decibels of a power increase from 20 watts to 200 watts? Now in this case, look what's happening here. You're basically adding 1 0. So like I said before, if it's 10 dB, you're adding 1 0 because it's based on that 1 and the 10. And there you go. And you're done. I like it when we get 100. It's my favorite score. All right, let's do subcategory again. One more, because we're at 7 minutes now. I don't have a calculator with me, but we could do some Ohm's laws. Let's do electrical components. That sounds like fun. Which electrical component is used to oppose the flow of current in a DC circuit? Well, it's not a voltmeter. Transformers do not transform DC. Pulsating DC, yes, but straight DC, they do not. Inductors, that's an interesting one there because, and almost a trick question, because an inductor, if there's a surge of current flow through an inductor, it will try to oppose it. And then, unless that keyword is oppose, instead of resist the flow of current. So we'll try inductor because, I mean, resistor kind of does the same thing, but, you know, oops, we were wrong. So it must have been. I wonder if it lets me pick again. Yes, it does. That's a good thing to know. I didn't know that. Okay, so was resistor. I don't really care for the wording of that. To me, it was somewhat of a trick question. But anyway, you do know the right answer, even though it says oppose. What type of current, or excuse me, what type of component is often used as an adjustable volume control? That is better known as a potentiometer. I really don't know. Well, yeah, actually, I mean, if a voltage is a potential and you're able to vary it, maybe that's where they get potentiometer from. I honestly don't know. I've always just knew that that's what it was called and didn't really care. Anyway, fixed resistor would not be adjustable. A transformer is not adjustable. Power resistor is not adjustable. So, there you go. What electrical parameter is controlled by a potentiometer? Resistance. It's what a potentiometer is. It's a variable resistance device. A component, actually, not a device. What electrical component stores energy in an electric field? Okay. Mincing a little bit of the word here. Electric field. Okay, now, if it were, it's not a diode. A diode, just so you know, allows current to flow in one direction. It's like a one directional switch. Capacitor, we'll go back to that. Resistor doesn't store energy, and an inductor stores energy in a electromagnetic field or a magnetic field. So it's most likely that one. That's good because I only got a 67. You see that? Oh no, we're at 75 now. Oop, oop. What type of electrical component consists of two or more conductive surfaces separated by an insulator? That is, no matter how you put this, is always going to be capacitor, because that's exactly what a capacitor is. I mean, you could take a glass jar, like what are those jars? Those bell jars that you can with. You could put aluminum foil on the outside. You could put aluminum foil on the inside, hook a wire to each. That's a capacitor because it's two conductive surfaces separated by an insulator. You can make your own capacitor. In fact, you can make a thing called a Leyden jar. It's L-E-Y-D-O-N, I think. Not sure what that last part, whether it's D-O-N or D-A-N, Leyden. D-E-N, not sure. Anyway, that can store quite a bit of energy. If you're curious, look it up sometime. Anyway, capacitor. Don't mean to ramble. What type of electrical component stores energy in a magnetic field? I discussed that earlier. That is an inductor. And the reason that is because an inductor has an iron core, typically in wire, and when you put or you pass current through an inductor, it causes a magnetic field to be created, and when that magnetic field collapses, either be it part of a frequency type thing like 60 hertz, or whether it be just DC current flowing through it that's just not changing, and then you shut off the DC current, that magnetic field will collapse and create a voltage, induce a voltage on that wire and that inductor. So that's how it stores its energy in a magnetic field. Capacitor is a electric field, and these two do not do that. Okay. What electrical component is usually composed of a coil of wire? That's an inductor, always and forever. Transformers are a form of inductors, but it's not a coil of wire, there's multiple coils of wire in a sense. So that's why, well, if transformer was in here it'd be confusing, but a transformer is an inductor as well. Just not in the conventional sense as far as, theory and such, as far as, what do I want to say? If somebody says you need an inductor in that circuit, you're going to think, like a toroid with some wire wrapped around it, that kind of thing, not necessarily a transformer. Anyway, which electrical component is used to connect or disconnect electrical circuits? Always a switch. And a switch does what's called completing the circuit. So, and in electronics, you always have to have a complete circuit for current to flow. If you do not have that, the current will not flow. And so a switch interrupts that flow of current. It's not inductor. I mean, I'm just trying to think if there's any reason to explain those, and there's really not. If a Zener, yeah, I can't even use a Zener diode in this case. A regular diode would affect the flow of current if it was in the path in the correct direction, but it's not its function. That's not what it's designed to do. Okay, which electrical component is used to protect other components from current overloads? That it always a fuse. You guys know that. Circuit breakers, fuses. I mean, that's what they're for. I don't know if anybody doesn't know that that's not what they're for, so I'm not going to dwell on that one. What is the nominal voltage of a fully charged nickel-cadmium cell? Fully charged, well, this is typically an alkaline cell here. I'm going to say 1.2, although I find that interesting because I thought that a fully charged nickel-cadmium was like 1.35, but I could be wrong about that. Or maybe the question's just a little off, but just remember it's 1.2. It's the closest answer in that question anyway, so it doesn't really matter. Which type of battery is not rechargeable? Well, that's kind of a trick question. Nickel-cadmium is, lead acid is. Lead acid is your car battery, batteries that are in your uninterruptible power supplies that are hooked to computers or in the emergency lighting. Lithium ion is most definitely rechargeable and capable of delivering a fair amount of current per unit size, kind of a thing. They're small, but they pack a lot of current. Nickel cadmium tend to develop what's called a memory. You have to watch the discharge charge cycle. Although I was told the newer ones don't really have that issue anymore. I don't know if that's a myth or not, but if you have a choice, get nickel metal hydride or lithium ion. They're better anyway, in my most humble opinion. And anyway, the answer is carbon, zinc, what lots of times they call an alkaline battery, and to a small degree you can put a little bit of juice back in them, but you can't really keep recharging them over and over again like you can with the other ones. So hit that. All right, so we're done again. Missed one, I guess. So anyway, that's that. I mean, it's 15 minutes long, so I don't want to make these too long. And I guess that's the first of a series. So thanks for watching. And again, any comments, leave them below. Anything to talk about you want to see a little more in depth or a video on, put it in the comments below. If you like the video, please click like and feel free to subscribe. The more the merrier. Thanks everyone for watching. 7-3.